Well, we're back.
Howdy.
This is Mr. B.
Mr. Sam's here.
Hey, what we want to do today is kind of get you an introduction to kind of a little bit about ourselves. So I think it's Mr. Sam's turn today.
Yeah.
So, Mr. Sam's, tell me a little about like when you were like in high school. I know that was like forever ago.
Yeah, well, that's not one that long. 15 years.
15 years?
Yeah, it's been a while.
I don't want to ask how long it was.
Let's see. I always liked science and stuff, but I was really into
So
music.
you're a science geek.
Yeah, sort of, but I was really into music. I started out college as a music major.
Music
and then I switched
major.
to science. I was a trumpet player.
Trumpet? You kind of look like a trumpet guy.
Yeah, kind of jerky and arrogant. Yeah. That's kind of how we typically are. Yeah, but that was my band.
Your thing
I was
was
in
trumpet.
band and jazz band and an orchestra and all sorts of stuff like that.
So you like went to school like music scholarship or whatever?
Yeah, I did until I
Nice.
switched majors and I lost that one and had
So-
to scrounge up some cash.
Well, there you go.
Yeah.
So, the music major, introduction to the music major, cool. Well, folks, what we want to do today is we want to talk about the properties of matter.
Yes.
And Mr. Bergman has a pin problem. He must turn his pin on. I
Yes.
see. There we go. I have the pin on the properties of matter.
Yeah.
So matter. What's up with
Yeah.
matter?
What's the matter?
Well,
That was dumb.
what's the matter?
Yeah, I won't do that again.
Ouch! Woo!
Whoa.
Painful, man.
Yep.
All right. What is matter, Mr. Sams?
Well, it matters anything that has mass
Mass. Okay, mass.
and a volume or takes up space.
Mass and volume. Okay,
Yep.
so let's talk some more about that. Oh, well, we have a rock.
A rock has mass.
Yeah, I think
and
so.
it also takes up space.
Takes up that rock takes
Yeah.
up a lot of space. That's
does.
a big honking rock.
Yeah, I went on a hike with my son last weekend, and he learned about moss and lichen and all
Oh,
sorts
nice.
of fun stuff. Yeah,
That's cool.
He's a
Or
little
here
science
we
nerd,
have
too.
like an ocean. An
yeah,
ocean, of
yeah.
course.
So the water in there, it has a mass and also takes up space,
Yeah.
so it's matter.
That would make sense, yeah.
Yeah.
Now here we have a picture. That's kind of an odd picture.
Ooh, dry ice.
That's
looks
dry
like.
ice
Yeah.
right there, guys. And dry ice, you can't really tell. This is what is
Well,
dry
that's a
ice?
solid. It's solid carbon dioxide.
Carbon dioxide. Yeah.
Yeah, and it's also looks like it's turning into gaseous carbon dioxide.
Yeah, so what you see here, guys, is you can see, I'm going to change the color here for us, is that right through here is it's turning into a gas.
Yeah. Now,
All right.
do gases do they have a mass? Gases have a mass?
Actually, yes, they do, Mr. Sims. A lot of
Really?
people think that gases have no mass. You might think of it as kind of weight. Not exactly the same thing. Take physics and we'll teach you how that works. But they have a very, very small mass.
Yeah.
So, and they take up space. They
They
fill
do.
the room. I'm breathing some
Yeah.
gas right now.
Yeah, don't believe me? Move your arms around. Flap them around like a bird, and you can actually feel the stuff. Yeah. You feel that? Yeah, I bet that was loud. Hopefully they have headphones on. But it has a mass, and it takes up space. You can feel it. It's there. There's something there. It's not just nothing.
Yeah,
Gas
indeed.
is something.
Now, matter has different properties.
It does.
So let's talk about that. So let's talk about density. All right. So what I've got right here is I have two different metal cylinders. The first one is made of copper, and I think the second one is aluminum.
Looks like aluminum to me.
And so, what would you say about their volume?
It looks like the volumes are about the same.
Yeah, they're the same size
Yeah.
in terms of volume, but if I hold them, one thing I can notice is that one is much heavier. So let me show you that
Okay.
on the scale. So if I put the copper one on the scale, you can see it has a mass of 56 and some change grams. That's in grams. All right. And if I take the aluminum and put it on to the scale, he only weighs like 17, almost 18 grams.
A lot less mass for the same amount of volume.
Yeah, so the same volume, if you were to have these in your hand, you would say, whoa, this one is really heavy. The copper one is heavy. The aluminum one is light. So that's a good illustration of density. It's really the mass divided by the volume. All right, the second thing we want to talk about is temperature. So if we come over here with the camera, I happen to have two flasks filled just with water. And I have a temperature, or a thermometer, pardon me, and this is what we call a digital thermometer. I'm going to push the on button right here, and it's warming up right there, and it's got degrees Fahrenheit. I don't know
Fahrenheit.
why. I'll turn
Who
that.
put it in Fahrenheit?
Which child did that? And so if we see this, it looks like the room temperature is like 26 degrees Celsius. And so I'm going to put the thermometer into the first container of water, and we can zoom in on the temperature, and it looks like we're at 22 and some change degrees Celsius. And I don't know if you noticed this in this second flask, but you will see that I have a small amount of ice. And so it is ice water, and so it should be close to 0 degrees. It's been sitting for a while, so it might be starting to be a little bit warmer.
Now, what are we actually measuring when we measure temperature, Mr.
That's an
Hartman?
important thing to understand. When you're measuring temperature, you're measuring what's called the average kinetic energy. to kind of put that in a more easy term, you're actually measuring the speed of the molecule.
Speed, is that another property of matter?
Yes, in fact, we could talk about it. Let's talk about speed of particles. So let's talk about the difference. What's the difference between the warm water and the ice water?
Well, if it's warm, they're probably moving faster.
Yeah, so if you were to somehow get at the molecular level, you would see the molecules zooming around. Ouch, my hand. Okay, they'd be moving quickly. Now, in the ice water right here, you would see them moving slowly. You like that?
Yeah, you're going to love that when you see that.
Slowly. You'll think something's wrong. So it's moving very, very slowly because the molecules are colder. Okay? Now, another physical property of matter is actually speed. So how could I illustrate speed? Oh, we skipped one, Mr. Sams.
What did we skip?
Temperature, volume.
Yeah.
Well, volume, these have volume. I think that's obvious. And speed. All right, so let me see if I can do this without killing myself. Mr. Bergman, let's come over here. And of course, when you are moving, you have
That's speed.
speed. So,
Whoa, he's so fast I can't keep up with him.
there you go. And back. And lastly,
Mr. Bergman runs triathlons, though.
yes. In fact, I have my USA Triathlon T-shirt on today. And lastly, you can also have color. I mean, this isn't an exhaustive list,
No.
but my vitamin water is reddish because this is the
Kind of matches his shirt.
blueberry pomegranate
Ugh, special.
special flavor.
So what's color doing? What makes something have a color? What
Actually,
do we
that's a
see?
good thing. Color's an interesting thing. Is that actually it's a reflection of light, and so we're in a room that has white lights from the top, and so as it comes into my red shirt, interesting thing happens. Actually, all of the light, all white light is actually a mixture of all the colors of light: red, orange, yellow, blue, green, indigo, and violet. And so all those colors hit my red shirt, for example, and only one color bounces off, and that would be red. So it absorbs everything but the red colors.
All right, and that is not an exhaustive list. There are a bunch of other physical
Yes.
properties, but there's a start for you.
Okay. There are also properties that are either intensive and or extensive, Mr. Sams.
Yeah. Now, intensive properties are properties of a substance that, regardless of how much of the substance you have, it still has that property.
So if I have like 1,000,000 grams of something,
Uh-huh.
its property stays the same.
The same as if you had 5 grams of something. Right.
So property doesn't change.
Right.
With
So that-
amount, maybe?
Right. Yeah. Property doesn't change with the amount. So an example of that would be density. We talked about it earlier. If I have a piece of aluminum,
Actually, let's use this example, Mr.
Okay.
Sams. I have a picture here of a liquid, and we've got 3 different liquids. There's one liquid at the bottom. Oops, what did I do? All right, there's one liquid at the bottom, and it is, well, what? Tell me about that.
that one's the most dense, meaning it has the greatest amount of mass per given amount of volume. And then medium density, and then the green one is the least dense. Now, that substance in the bottom, regardless of how much I have of it, it has the same density. That property does not change with the amount of the substance.
So if I were to pour some more of this
Uh-huh.
red substance on the bottom
Yep.
in here, what would happen to the density?
and the density would stay the same.
And where would it go, by the way?
It would the substance would flow down to the bottom with the rest of it down there.
Yeah, and so actually you would just make a taller stack, and the
Right.
red stuff would go to the bottom. So that's something to understand. It
Right.
does not change density.
Right.
What are some other examples?
Color doesn't
yeah,
change.
Yeah, if you got
Okay.
a red shirt and you
Yeah.
got the bolt of fabric it came from, it's
Right.
still
yeah.
red.
I mean, the small shirt has the same amount of redness as the large.
There you
shirt.
go. Yeah, that makes sense.
Yep.
Okay, and then how does that contrast with extensive?
Well, an
then?
extensive property changes depending on the amount that you have. So a property like that would be mass. If I have a small amount, I might have, let's say, 5 grams of a substance. Then if I have more of the substance, I have a greater amount of the substance. So it depends upon the amount of material present.
All right, so yeah, here is like a mass, some object. They've got a
Right.
little scale, just kind of like what we did a minute ago.
Mm-hmm.
They had 6.4 grams or ounces or whatever, I don't know what the unit is, of a substance. But if I were to have a bigger piece of this metal, it would weigh more.
It would.
So that is called an extensive property. Now, so Mr. Sams, we've talked about solids and gases in terms of their shape and volume and that kind of stuff. But if you were to kind of zoom in
Yeah.
at the molecular level, what would you tell me? How are they different?
Well, the gases are kind of spread apart and flying all around.
All right, so they're very far apart, folks. Way far apart, and they're moving because all molecules are moving.
Right.
Okay.
And then the liquids, they're still moving, but they're kind of attracted to each other a little bit. That's what holds them together.
So they're not actually like touching, though they kind of sometimes they're
they
bumping.
kind of
But notice how close.
slip around and
Yeah.
rub into each other, kind of like a crowded street in New York, I guess.
Yeah, yeah. And then a solid.
So they're attracted to one another. They're stuck together into a crystalline structure.
Now, are they moving?
They still are moving, yeah.
Yeah, and actually they kind of vibrate back
vibrate,
and forth. And so maybe think of like they're connected, and they probably are closer actually. It would be more like this.
Think of a densely packed dance floor. Everybody's smushed
Yeah,
together and
that
just
works.
kind of vibrating back and forth, I guess you could say.
Vibrating? That sounds something weird there, Mr.
Mm.
Sams. Yeah, I don't know if you're going to go there. And now, well, there's our picture zoomed in. I don't need it. Here's kind of a cool animation. This would be a what, Mr. Sams?
That's a solid.
Notice they're moving.
Yep. They're vibrating and the temperature's lower. Then you heat it up a little bit. Notice the temperature's going up. And they are spread out a little bit. They don't have that nice organized crystalline shape anymore, but they're not flying around like the gas is. Did you know that the word gas is a transliteration of the Greek word for chaos?
I did not know that.
Yeah.
Yeah, that's cool, though. That's
Yeah.
good to know. And then the gas, of course, they're flying all around, right?
Yep.
And we can see that also in this. This would be a gas. They're moving around and around. They're kind of randomly motioning, and they hit each other.
Yep.
They're like striking each other. We got two gases, the blue and the red.
Yeah.
I don't know what they represent necessarily.
Kind of, have you ever seen the lottery drawing on TV? All those
Oh,
little
yeah.
ping pong balls flying
Yeah.
around?
Yeah.
Looks kind of like that.
And so that's kind of the molecular view of solids, liquids, and gases.
There it is.
Well, guys, you've now watched your very first podcast.
There it is.
That's content. So
Yeah.
hopefully you pushed pause a couple of
Yeah,
times.
if you got stuck, push pause, push rewind, watch us again.
Yeah, watch
it
us
down.
again, and then you'll be good.
Yeah, we'll see you in
So,
class.
See you in class. Bye.